we were looking at the multiplier in our goods market model, where we said the multiplier tells us how much equilibrium output changes due to one unit change in autonomous spending, which could be a change in, say, C naught, I bar, G bar, or T bar, where autonomous spending is spending not related to income. We want to now look at features of this multiplier. The first feature, like we just said, is the multiplier will be in operation if any autonomous component or demand changes, component or demand not related to income. So this could be changes in investment. This could be changes in C, unrelated to changes in income, changes in G, changes in taxes, and so on. So the multiplier will be in operation if any autonomous component or demand changes that is not related to income. The second thing is that so far what we discussed was we were looking at the multiplier effect of an increase in G. But the multiplier works in both forward and backward direction depending upon the direction of initial change. An initial increase in autonomous spending will create a multiple increase in equilibrium output. Like we saw that when you increase G, so output increases more than the initial increase in G. But if instead of rising, autonomous demand falls, equilibrium income will fall to a multiplied extent, which means that if G falls, then output would fall by greater than the initial decrease in G. So the multiplier works in both backward and forward direction. Initial increase will result in a multiplied increase in equilibrium output, and an initial fall in autonomous demand will result in a multiplied decrease in equilibrium output. And this is a very important warning that this formula that we know of the expenditure multiplier 1 by 1 minus MPC and of the tax multipliers minus MPC by 1 minus MPC, this only holds in the special case in which only C depends upon Y, right? So only in that particular case in your model where only C depends upon Y, right? And I does not depend upon Y, G does not depend upon Y, T does not depend upon Y, right? So only in that special case in which only C depends upon Y do do these formulas. This formula holds for the expenditure multiplier, this holds for the tax multiplier. If any other component or demand depends upon Y, the formula for the multiplier will change. So the exact formula for the multiplier depends upon how each function in the macroeconomic model is formulated, and for each variant of the goods market model. And for any variant of the goods market model, we can find the multiplier using calculus or geometric series, like we found the government expenditure multiplier in an earlier video. Right, so just keep this in mind. This is an important warning that this formula for the expenditure multiplier and this formula for the tax multiplier only applies in that particular goods market model where only C depends upon Y. I does not depend upon Y, G does not depend upon Y, T does not depend upon Y. Now, next is the size of the multiplier in MPC. So an increase in MPC increases the multiplier so that changes in autonomous spending have a larger effect on equilibrium output. Now, why is that? Because we saw in the simplest model, the multiplier effect exists because when income goes up, consumption goes up, which raises demand and income so that people consume more and so on, right? So if we go back, when we looked at the mechanism of the multiplier effect, here. So we looked at the mechanism of the multiplier effect. So we said, okay, when Y increases, that increases C, which further increases demand, which further increases Y. And this increase in C that happens because of the increase in Y is the beginning of the indirect effects of the shock, which is the reason why an initial change in G results in a greater effect on equilibrium Y, because it, in addition to the direct, it also has indirect effects in Y. So we know in the simplest model, the multiplier exists because when income goes up, consumption goes up, which raises demand and income so that people consume even more and so on. So if MPC is high, so if the larger the MPC, the more consumption rises as a result of an increase in income at each stage of the multiplier process, causing a larger multiplier effect. Like at each stage when Y increases, C increases, the larger the MPC, the larger the increase in C. Right, so here when Y increases, again C increases. So when MPC is high, then at each stage of the multiplier process, the increase in consumption due to increase in income is high. So you have an overall larger multiplier effect. So the next is we can use the multiplier to relate changes in equilibrium output to changes in autonomous spending. Because recall, multiplier tells us how much equilibrium output Y star changes due to 1 unit change in autonomous spending. So if autonomous spending changes by delta autonomous spending, then we can say change in equilibrium income is multiplier times change in autonomous spending. Because multiplier tells us how much equilibrium income Y star changes due to 1 unit change. So if autonomous spending changes by delta autonomous spending, we can write change in equilibrium income as multiplier times delta autonomous spending. For example, assume the government expenditure multiplies 4. How much would equilibrium output change if government spending increases by 10 units? we know change in equilibrium income would be government expenditure multiplied times delta G. Right over here, this was in general for any change in autonomous spending. Here, autonomous spending that's changing is G. So we can write this as delta Y star into the government expenditure multiplied times delta G. So here the multiplier that we're talking about is the one relevant for this particular spending component. So here if we're looking at change in government spending, so we'll use the government expenditure multiplier. If you're looking at change in investments, we'll use the investment multiplier and so on. So government expenditure multiplies 4 here and government spending is changing by 10 units. So we can say change in equilibrium Y is 4 into 10 is 40. So this equilibrium income will increase by 40 units. So if we change G by 10 units, equilibrium income will change by 40 units. And as we can see, the increase in Y is greater than the increase in G because of the effects of the multiplier. What if the government wanted to increase equilibrium Y by 200? What change in G would be required? Again, we know that change in equilibrium Y is government expenditure multiplier times change in G, where the government expenditure multiplies 4. And here we want the change in equilibrium Y to be 200. So we can put this as 200, this is 4. And here, from here we can see that the change in G would be 50. So note, since any change in G will set a multiplier process in motion, the increase in G 50 required is less than the required increase in equilibrium Y 200. So in this way, we can basically use the multiplier to relate changes in equilibrium income to changes in autonomous spending.